Welcome back all my dear students. In today's lecture we are going to see the design of a double reinforced section. Okay. In previous lecture we have seen the concept of double reinforced section, necessity of double reinforced section, and we have derived some equations to solve or analyze the problems on the double reinforced section. In today's topic we will see how to design a double reinforced section. First, I will explain the steps to be followed in the design of double reinforced section, and next we will solve one numerical on the design of double reinforced section. Okay, so let us start with the design steps for the design of double reinforced section. So, what will be given in the numerical when they will ask you to design? So what will be given? The given values will be width of beam will be given, the depth of beam will be given, FCA, FY and factor bending moment MD will be given. But they will give you the working bending moment. You have to multiply it by 1.5 to calculate MD value. So factor bending moment MD will be given. So now what you have to find out? You have to find out the value of reinforcement on tension side, and you have to find out the value of reinforcement on compression side. In the design of singly reinforced section, the depth of beam you have to find out, the AST you have to find out. But here the depth of beam, width of beam will be given. You just have to find out the reinforcement amount in compression side and in tension side. Okay. Now, so step number 1. What will be step number 1 in the design process? Okay. So first step is to find out MU limit value. Is to find out limiting moment of resistance, MU limit values. 0.149 mckb square, 0.138 mckb square, and 0.133 mckb square. This is for FE 250, 415 and 500. Similarly, in the same location, you have to find out the exit limit value also. 0.53D, 0.48D, and 0.46D. Similarly, this is for 250, this is for 415, and this is for 500. Okay? So first, in the first step, you have to calculate the design constants. Simply, you have to find out MU limit and exit limit. In next step, you have to check which type of beam it is, whether it is singly reinforced or doubly reinforced. Okay, sometimes in the exam they will not mention specifically whether the beam is to be designed as a singly reinforced or doubly reinforced. So in that case, you have to identify first whether the beam is singly reinforced or doubly reinforced. So how will you identify? So that is your step number 2. Okay, you have to check the beam whether it is singly reinforced or doubly reinforced. So how will you check single? If MD is less than or equal to MU limit, then it is singly reinforced section. Then it is singly reinforced section. If MD is greater than MU limit, then it is doubly reinforced section. Then it is doubly reinforced section. Okay, so this is your step number 2 to identify the type of beam, singly reinforced or doubly reinforced. Okay, then step number 3. Step number 3. Now in step number 3, you have to calculate extra bending moment. whatever it is there, extra bending moment, mu additional. And this will be equal to md minus mu limit. This will be equal to md minus mu limit. So this is how we can calculate the value of additional bending moment. Then you have to calculate AST value. Step number 4. Calculate AST 1. See, you have to calculate AST 1, AST 2 and ASC. These three values you have to calculate. Then you have to calculate total AST by adding AST 1 plus AST 2. And in the answer you have to mention what is ASC and what is total AST. In the answer you have to mention two values, total ASC and total AST. How will you calculate AST 1? See, mu additional is equal to md minus mu limit. Okay, so we have already seen. So total section will be split into two parts. One is single reinforced and second is the section to carry the additional moment. So this is your additional moment and this is your moment resisted by the single reinforced section. So this is your mu limit. And this total is your MD. So total moment of resistance MD will be equal to mu limit plus mu additional. This is my AST1, this is AST2 and this is AST. So this AST1 is still required for this balance section. AST2 still required, tension still required for this additional bending. So first I have to calculate AST1. So AST1 is still required for the single reinforced section or balance section. So how will you calculate this? It is very simple. So you have to use equation for the calculation of steel for single reinforced section. Compression is equal to tension. That is 0.36 B into XU limit. Because see, this mu1 mu is equal to mu limit. This particular mu is equal to mu limit. Additional moment हा सेक्शन घेणार आहे आणि जो बॅलन्स मोमेंट आहे तो हा सेक्शन घेणार. सो बॅलन्स साठी स्टील लागणार आहे म्हणजे mu लिमिट साठी लागणार स्टील. इट मीन्स यू हैव टू टेक XU value as the XU limit. Okay, tension is equal to 0.87 Fy into AC. So if you substitute all the values over here, you will get 0.36 FCK B into XU limit 4 divided by 0.87. So this is how we can calculate AST1. Then step number 5, calculation of AST2 and AC. Calculation of AST2 and AC. So how will you calculate this? We know that we have derived one more equation, that is mu additional is equal to AC into bracket FSC minus FCC. So now mu additional we have calculated in step number 3. You have to substitute the value of mu additional. FSC and FCC you can calculate it from the chart. FSC can be calculated from the chart and FCC is equal to 0.446 FCK. Okay. Then you can calculate value of ASC, that is only one unknown value over here. Okay. So this is how we can calculate ASC. Now how will you calculate AST2? That is one parameter is missing now. Again you can use this equation mu additional. Who is going to resist this mu additional, this ASC and this AST2? Okay, so you can use this equation 0.87 Fy into AST2. Sorry, I forgot to write the equilibrium here. into d minus d. So you will get again, if you substitute all the values of any additional value you can put here. F1 value you can write according to the grade of steel, d minus d dash. If you substitute all the values you will get AST. Okay. So we have calculated AST1. We have calculated AST2, we have calculated AST. So total AST will be AST1 plus AST2 and ASC from this equation. Once you calculate the ASC, instead of using this equation, you can use equation additional tension is equal to additional compression, means 0.87 a point to AST2 is equal to ASC into bracket FSC minus FCC. So that equation can be utilized here to calculate AST2. Okay. So this is how very simple you can calculate the reinforcement for the double reinforced section. So it's a 5-step process. First we have to calculate design constants, ME limit and XT limit. Then you have to check whether the section is singly reinforced or double reinforced. Then you have to calculate the additional moment of resistance MD minus MD limit. Then you have to calculate AST by using equation compression is equal to tension. Here you have to substitute the value of XU as the XU limit and you can calculate AST1. Then to calculate AST2 and ASC, you have to use this equation when you additional is equal to ASC into FSC minus FC multiplied by T minus D dash. Where the FSC is equal to stress in compression steel can be calculated from the chart. Okay, and FCC is 0.446 FCT. So from this equation you can calculate ASC. Similarly, by using same equation but changing this particular term, that is here this compression, you have to substitute the tension 0.87 a point to AST2. You will calculate AST2 value, and then by adding this AST1 and AST2 you will get total AST. Similarly, you can calculate total. You can take the value of AST over here. In the answer you have to mention two reinforcement, compression reinforcement and tension reinforcement. Okay. So now we will solve a numerical based on this. So I will read the numerical for you. Please note it down and then we will solve. Okay. A beam 250 by 500 mm effective size carries a factored moment MD of 165 kilonewton meter. I repeat, a beam 250 by 500 mm effective size carries a factored moment MD of 165 kilonewton meter. Find area of steel required if M15 concrete and mild steel are used. Find area of steel required if M15 concrete and mild steel are used. Effective cover D dash is equal to 50 mm. Effective cover D dash is equal to 50 mm. Okay, so we will solve this. Okay. Now, as I mentioned, the width of the beam is given, it is 250 mm. The depth of beam is also given, it is 500 mm. Then effective cover is also given, it is is 50 mm. FCK grade of concrete is given as M20. Sorry, M15 is given. M15 means FCK is equal to 50 Newton per mm square. Then Fy is given. It is 250 Newton per mm square. We have to find AST. We have to find ASC. One more term is given, that is MD, factor moment, and it is 165 kilonewton meter. It means 165 to 10 raised to 6 Newton mm. Okay. So step number 1 is calculation of design constant. So MU limit. So now we are using grade 250. So formula for MU limit is 0.149 FCK B square. Substitute all the values. 0.149 FCK 50, B is 250 and D is 500 square. If we substitute all the values, you will get MU limit as a 139.69 kilonewton meter. Okay. Similarly, we will calculate XU limit for this particular grade. XU limit value can be calculated as 0.53 D. We substitute the value 0.53 D is 500. We will get XU limit is 265.5 mm. Okay. Next, we have to check whether the section is singly reinforced or doubly reinforced. Step number 2 is identifying the section. So for that we have to check the MD value and MU limit value. So MD is 165 and MU limit is 139.69. It means MD is more than MU limit. MD is more than MU limit. It means section is to be designed as a doubly reinforced section. Section is to be designed as a doubly reinforced section. Okay. Then step number 3 is calculation of additional moment of resistance, MU additional. What is the extra amount of bending moment? We will calculate. So we will calculate simply MD minus MU limit. So MD is 165 minus 139.69. We will get MU additional 25.31 kilonewton meter. Okay. Then step number 4, calculation of AST1. Calculation of AST1. So for that we will use compression is equal to tension equation for the singly reinforced section. Compression so compression is equal to 0.36 FCK B into XU limit. I am putting here XU value as XU limit because first section is balance section and second section will be section required to register additional moment. Okay. So this XU value will be XU limit and and tension is equal to 0.87 Fy into AST. I will substitute all the values and calculate the XV limit. So now 0.36, FCK is 15, B is 250, XV limit is 265.5 is equal to 0.87, Fy is 250 and AST is to be calculated. So if you solve this, you will get value of AST as 1650 mm². 1650 mm². So now next point is calculation of ASC and AST2. Okay, so for that we know the equation mu additional is equal to ASC into bracket FSC minus FCC into bracket multiplied by D minus D dash. So now FCC will be equal to 0.446 FCT. Okay, so it comes to 6.69 Newton per mm². And what is FSC? Now we are using grade of concrete, so steel as a 250. So FSC can be calculated by using equation 0.87. So 0.87 Fy is 250. So it gives the value 217.5. If the grade of steel you are using as a Fe 250, then you can take FSC value directly as a 217.5 Newton per mm². Okay. Now substitute all the values in this equation. Mu additional is 25.31. Now see, when I am going to put in this particular equation, I will put the values in Newton mm, because all the values are in Newton mm. ASC I have to calculate FSC 217.5 minus 6.69, D is 500 and D dash is 50. So if you solve this, you will get value of ASC as a 266.8. As a 266.8. Now, similarly, we want to calculate AST2. So for that, I can use the equation mu additional is equal to, instead of compression into lever arm, I will take tension into lever arm, that is 0.87 Fy into AST2 into D minus D dash. You can use this equation. Okay. Similarly, you can use one more equation, that is compression into lever arm, means ASC into FSC minus FCC is equal to 0.87 Fy into AST2. So these are the notes which I am going to share with you. So in that notes, I have calculated the reinforcement by AST2 value by the other method, means ASC into bracket FSC minus FCC is equal to 0.87 Fy into AST2. So by using this particular equation, I have calculated the reinforcement. From both the equation, you will get same value. Okay. So now substitute here 25.3 into 10 raised to 6, 0.87 into Fy is 250. AST we have to calculate, and D minus D dash 500 minus 50. So if we solve this, we will get AST2 as 258.5. 258.59 mm square. So total AST will be AST1 plus AST2. This will be equal to is 1650 plus 258.59. This is 1908.59 mm square, and AC is your 266.8 mm square. Okay. So this is how you can design a doubly reinforced beam. So what I have done, first step I have calculated the design constant, then I have checked whether the section is single reinforced or double reinforced, then I have calculated the additional moment of resistance, then calculation of AST by using the concept of single reinforced section, but only I have substituted the value of x to the x to the limit. Calculated the reinforcement AST1 as a 1650. Then I have calculated ASC and AST2 by using same equation. Mu additional is equal to ASC into FSC minus FCC multiplied by D minus D dash. Same म्हणजे काय आहे, इथे मी कॉम्प्रेशन घेतलंय आणि इथे मी टेन्शन घेतलंय. इक्वेशन सेम नाही पण इक्वेशन जो कन्सेप्ट आहे फोर्स मल्टिप्लाइड बाय लीवर तो सेम. ASC into bracket FSC minus FCC into D minus D dash, and here it is I have taken 0.87 F point ASC2 multiplied by D minus D dash. Okay. And by substituting the other values, I have calculated ASC and AST2. So total reinforcement on tension side AST will be equal to AST1 plus AST2, and this is ASC. Okay. So this is how you can design a double reinforced beam. In next lecture we will see how to analyze the double reinforced beam. In that case the reinforcement will be given, the specifications, other specification, that is size of beam will be given, and they will ask you to find out the moment of resistance or total moment of resistance of the particular section. Okay, thank you.